In recent years, there has been an explosion in the amount of text data from a variety of sources. This volume of text is an invaluable source of information and knowledge, which needs to be effectively summarized to be useful. With the dramatic growth of the internet, people are overwhelmed by the tremendous amount of online information and documents. Document summarization is process of generating summary from either single or multiple documents. A summary can be defined as a text that conveys only the important information from the original text. Document summarization is achieved using automatic text summarization, which is task of producing a concise and fluent summary while preserving key information content and overall meaning. Basically, automatic text summarization make use of text mining and natural language processing. Text summarization can be classified into various types. Based on input, single or multi-document summarization. Based on context, domain-specific, generic and query-based. Based on output, extractive and abstractive summarization. There are a lot of text summarization methods or algorithms available. Some of the well-known are positional method, Lund's method, Edmondson's method, Frump, classification, clustering, Mead, TextRank, LexRank, sequence-to-sequence, latent semantic analysis and many more. Some of them are traditional, while some of them are the newest. Every one of them has their different use cases and can give better output than others in some specific domain. Some are good to use in search engines, some in document summarization, while some may give better output with less input size. Before seeing which one of this is a good summarizer, let's first see what makes a good summary. To create any good summary, our goal must be to optimize the topic coverage and optimize the readability. Now let's look into the different evaluation criteria for summaries. One of it is salience, means are we capturing the most salient features of the text. Length, means is the length of the summary good? We do not want it to be too short or too long. And structure, meaning whether the content of summary is well structured and coherent, means whether we are able to read it and correctly. Then, balance, that is, are we covering all the topics from original document? And grammar, whether it is correct. And then the non-redundancy, which means, are there still any parts left which can be removed and still get the information we want? And now one of the things that we like to see here is, we want to optimize this information content. Basically, we want to optimize the compression and retention ratio. Where compression ratio tells us what is the percentage of information that ended up in the summary and retention ratio tells us what is the percentage of information of original document that is preserved in the summary. So what we want is a summarizer with low compression ratio and high retention ratio. Which means we want as much information possible in shortest amount of words. After reviewing a lot of research papers and online documentations available on document summarization and then testing different methods like LexRank, Lund, LSA and TextRank on a BBC News report, we concluded LSA to be a good summarizer for document summarization purpose. Now let's see what LSA is. Latent semantic analysis is the combination of algebraic and statistical methods that brings out hidden structure of words, between words, sentences or documents. It is an unsupervised approach along with usage of natural language processing. It extracts the input document and convert it to sentence term matrix and process it through an algorithm called single value decomposition. SVD finds relationship between word and sentences and also model relationship among sentences and words. Finally, output is obtained from SVD algorithm. There are 3 steps involved in LSA. First, the generation of document term matrix from the input data. Then, fitting it into SVD algorithm. And then, selection of sentences from the SVD output, which is our actual summary. Let's see how it works. Consider a document containing following sentences. It can be represented as document term matrix like given here. We have used binary data representation method to represent data in matrix. Where each row represents one of our documents, here one of 3 sentence fragments. Each column represents a word from the dictionary that shows at least one of the 4 documents. Then, the document is converted into a vectorized bag of words, which is then fitted into SVD algorithm, which gives the encoded matrix as output. This encoded matrix with its absolute value gives us better understanding of what each topic represents. It also represents how the sentence 1 and sentence 2 are more about OpenGenius, while sentence 3 and 4 are more about machine learning, as it represents the strength value for each topic. Here our main topics represented are OpenGenius and machine learning. Now, we need to extract the sentences from both the topics. Thus the obtained sentence from the first sentence will be intern at OpenGenius. And second sentence we got is ML developer. We practically implemented the LSA summarization and created a document summarizer software in Python. Here, we have taken a large file with a story. Using the document summarizer, you can select and add the document which you want to summarize and then click the Generate Summary button, which then gives you the summary of document in the side panel. There are a wide range of applications where a document summarizer can be useful. It can be used by doctors for summarizing medical reports. News articles can be summarized to provide insights. It can be used for producing intelligence reports from wide range of documents. Also for summarizing books, research papers, other educational documentations, search engine results and web pages, etc. Thanks for watching.